Hello everyone. In this video, we're going to be solving a non-standard trigonometric equation. Is it actually trigonometric? Well, we have sine x, so let's consider that this is a somewhat trigonometric equation. We have sine of x is equal to x over 100, and we're going to find the number of solutions this equation has. X is measured in radians here, so since we don't have the degree symbol, right? And how do we find the number of solutions of something like this? I mean, obviously this is non-standard. We can't solve this in standard ways, but we can look at it from different perspectives. First of all, notice that sine of x, or sine in general, is bounded, which means that sine x is always between -1 and +1 inclusive. Now, what is that going to give you? Well, sine x is equal to x over 100, so let's replace sine x with that. And this should give you an interval for x, which is good because we at least get like an upper boundary and a lower boundary for the x values. So we're going to be looking for solutions on that interval. Okay, so x needs to be between -100 and 100. And of course, in this case, x can equal 100. But if you think about it, obviously it can't because it doesn't satisfy the equation. If you replace x with 100 or -100, it's not going to work. But those are the boundaries that we have. Now, how do we use this information? First of all, consider that 100 can be written using pi, and just consider the fact that 100 is actually between 32 pi and 31 pi. So 100 is a little greater than 31 pi. So that information is important. So since we have the symmetry, if you consider the graph of the sine function, it's symmetrical, it's an odd function. So what we can do is we can kind of consider the positive solutions first and then reflect them, okay? So how do you find the solutions? Well, first of all, we're going to be considering the following interval. Consider the interval 0 to 100. And in this case, since I'm going to be dealing with positives and negatives separately, let's go ahead and not include 0 in this case. So let's consider this interval here. Now, I can go ahead and partition this interval into pieces, but let's go ahead and take a look at the graph of these functions first, because as you know, analytically, we can take a look at the graph of these two functions and see where they intersect, because basically we're looking for intersection points. And here's what that looks like. So we have the graph of y equals sine x in red, and the blue one is y equals x over 100. Obviously, that's a line with a very, very small slope, so it's almost horizontal. But obviously it's not, so that means it's going to go up and up. And obviously we have a limited or we have an interval for x, it's bounded, right? That means at some point the graph is just not going to intersect the blue graph is not going to intersect the sine function anymore. So that's pretty much what we need to do, and we kind of got an idea. If x values are greater than 100, we're not going to get any solutions. So we only need to look at the solutions on this interval. Make sense? So what we're going to do is we're going to partition that interval into pieces. But one of the things I want you to notice is that 0 is a separate case. It's kind of special. So let's go ahead and look at 0 separately. But if you consider this function here, we're getting a solution right here, somewhere here, and another solution here. Obviously, that second solution is greater than 2 pi, because at 2 pi, the graph will intersect the x-axis and then go up and intersect the blue graph, which is y equals x over 100. All right? So, and the other one is obviously y equals sine x, as you know. So, what is that supposed to mean? Well, we have an interval here, which is 0 to 100. Let's go ahead and partition that interval into pieces, okay? So we're going to go ahead and partition it into the following pieces. We're going to start with 0, but 0 is not going to be included. So we can look at it 0 to 2 pi, and then we can look at it 2 pi to 4 pi. Of course, the upper values are always included, so on and so forth. And this is going to go up all the way to 30 pi, and then, of course, at 100, we're going to stop. So since 100 is greater than 31 pi, this is going to work, and it's going to be less than 32 pi. Great. So that's those are the pieces that we're going to be looking at. And obviously, we're going to get pretty much the same number of solutions on those intervals, right? Well, let's take a look at the graph. Here, not that one, we have to go down. So if you look at the graph, you'll notice that we only get one solution on the interval 0 to 2 pi. So we got one solution here. One solution, okay. But does that mean we're always going to have one solution? Nope, not necessarily. Starting at 2 pi to 4 pi interval, you're going to have two solutions. Okay? If you look at the picture, and obviously the graph is not going to fit, that's too large, but starting at 2 pi, we're going to be getting two solutions for each of these intervals, including the last one. And let me show you the last one so you also get an idea what that looks like. Here we go. So the last piece here is basically you have the 30 pi here, which is where the sign is 0, and you have the 31 pi, and obviously 100 is greater than that, but as you can see here on that interval, we're going to get two solutions as well. And of course, after this point, the blue graph is no longer going to intersect. So we're not going to have any solutions outside. Okay? So what is that supposed to mean? Well, this means that we get this many solutions. So 2 through 30, we're going to count the even numbers. That gives us 15 intervals. Each interval has two solutions, so we get 15 times 2. And then if you include the 0 to 2 pi interval, that's the number of solutions we're getting. So we get 31 solutions on 0 to 100, where 0 is not included. Okay? Well, if you just go ahead and reflect this upon the y-axis, it's going to be the same story. You're going to get 31 solutions on the interval negative 100. Of course, in this case, you have to include it to 0, and 0 is not included. What about 0? What happens at 0? Let's go ahead and take a look at it separately because this is such a special case, right? Well, if you look at the function carefully, sine x equals x over 100, x equals 0 is a solution. And you could see that on the graph here too. 0, 0 is a solution. So we do have one solution from there by setting basically this equal to 0. We're getting x equals 0, and x equals 0 is a valid solution. So we get one solution at x equals 0, and that gives us what? The total number of solutions. There are 31 plus 31 plus 1, which is equal to 63 solutions to the equation sine x equals x over 100. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.